Section 9.5, we are going to talk about variations, which you have done before, not necessarily in here. We're going to talk about direct variations. We are also going to talk about joint variation. And inverse variation. Joint variation, or direct variation, excuse me, exists as the following. If there are 12 boys for every 15 girls, how many boys are there for 20 girls? That's called a direct variation. Direct variation means, in this case, as the number of girls goes up, what should happen with the boys?
They should go up too.
They should go up too. Alright? Does that make sense?
Yep.
As the number of girls went down, what should happen to the boys? They go down also. You used to set that up as, I'm going to put the number of boys over girls equals the number of boys over girls. That is one form of a direct variation. Could I have put girls over boys and girls over boys? Absolutely. So to solve this, you could have gone 12 times 20, which is 240, equals 15 times the number of boys. 15 goes into that how many times? Nobody has their calculator out.
16.
16 would equal the number of boys then, right? Okay? This works, but as we get into joint and inverse variations, it becomes a little more complex. With direct variation, this is generally the easiest way to solve the problem. But we also have a formula that goes along with that. It looks like this. Y equals kx. This little k is called constant of variation. How does it work with the boys and the girls and all that kind of stuff? Well, I'm going to change this formula to reflect boys and girls. Instead of y's and x's, I can either write the formula this way: boys equals constant of variation times the number of girls, or I could write it as the girls equals the constant of variation times the boys. Either way, but I'm still using this form. Right? What this is basically saying, as the number of girls goes up, the number of boys goes up by this multiplier. Or, as the number of boys goes up, the number of girls goes up by this multiplier. I don't care which way you write it. I wrote it as B's and G's to reflect boys and girls from up here. You can even leave it as y equals kx, but then you have to remember which one was my y and which one is my x. So that's why I wrote B and G. So if I'm using this idea, this concept, I replace numbers. Don't I know that 12 boys equals K times 15 girls? So can I find the K? By taking 12 over 15, which can be reduced to 4 over 5. Or for those people that don't like that, 0.8.
Bless you. Thank you. Bless you.
All right? Okay, well, how can I find if there are 20 girls? Okay, if there are 20 girls, I started out with this particular formula, didn't I? B equals KG. Reuse that same formula and put in the new numbers that you know. So I'm going to use B equals KG again. This time I don't know the boys, do I?
No, so B equals K times C.
Do I know the K?
Yeah.
Right here.
Oh.
I just found it, didn't I?
4/5 or 0.8.
0.8 times the number of girls is 20. So the number of boys is going to be 0.8 times 20, which is 16. Or for those of you that don't like the decimals, I could have replaced it with 4/5 times 20. Well, this will cancel with this, giving me a 4. B will equal 16. Okay? That's direct variation. Okay? Direct variation.
Well, that's not too bad.
Really, it's not too bad.
Pretty simple.
Okay?
Right. How is that gonna be harder?
No, not really.
Oh, yeah.
Key words. Varies directly, right? And didn't I just give you a formula for varies directly of y equals kx? Well, I'm worried about worms and fish, right? Does it matter which one's the worms and which one's the fish for the y and the x? So I would put a letter in. What do you want the y to be? Fish? Okay, so I put it as an F. What do you want the x to be then? W. Could I have written it as W equals KF? You bet. Okay, so the first thing I need to find is the constant of variation, isn't it? So from the original numbers, don't I have 2 worms and 5 fish?
Yes.
So I could put in 5 fish equals K times 2. So my K would be 5 over 2. All right? Using the same formula again, F equals KW. Right now I know what the K is, don't I? Which is 5 over 2. And what else do I know from the problem? I know the number of worms, don't I? Which is 7. The new data, right? The new data says 7 worms. So how many fish do I have? About 35 over 2, which means I'd have like 17 and a half fish.
Oh, you can have a half.
18.
You go catch half fish, Eric. Okay.
Well, that's sort of like the statistics that the United States, for a long time, the average family was 2.5 kids. How would you like to be the half a kid?
What if you're reeling your fish and then gone?
Okay? Do you understand direct variation? Do you understand this expression?
Yeah.
As x goes up, y goes up. And I can change that either way with F and W. I would make this switch whenever you're doing things dealing with other items other than x and y. So that you know that you have to use it here and the same one down here. You use it twice.
You just divide that 2 each time, right? That's what
Yep.
I'm doing. Okay.
Yep. All right? Inverse variation can also be solved as a ratio, but it becomes difficult to remember which way to put over which thing. Inverse variation basically means as one goes up, what happens with the other one? It goes down. Okay? Here is what the inverse variation from our discussion before looks like. Y equals K over X. As one goes up, the other one goes down. So here, the number of boys is inversely, I spelled that wrong,
That's okay.
proportional to the number of girls. You know, just like that problem we had before, right? If there are 12 boys for 15 girls,
There would be 12 girls and 15 boys? Is that what it means?
how many boys for 20 girls? Okay, inverse means the number of girls goes up, doesn't it? Right?
Boys go down.
So that means my answer had better be smaller for the number of boys because of the inverse proportion. I know I'm using the same numbers, but the key word here is the inversely proportional, right?
Yeah.
Does that make sense? Okay? So that means using y equals kx form, y equals k over x, I'm going to write it with girls and boys. Again, it doesn't matter which one you replace in for the y or the x, meaning I could write it as boys equals k over girls, or
Girls equal K over boys.
I just have to use the same one both times. Are we all right with that idea? Okay? Which one do you want to use? This one or this one?
12 equals K over 15.
Okay?
And girls and boys are
So you want to use the boys equals K over G.
Yep.
Okay? So we'd have 12 equals K over 15. How am I going to find K? Don't I cross multiply? This is like putting this over 1, isn't it? So 12 times 15, I believe, is about 180, equals K. Big number, I don't care. That's what it is. It's just what it is. Using the B equals K over G again, I know the K this time, don't I? Would you agree? Do I know the B? Nope. But I know the G.
B equals 180 over 20. You divide those, correct?
So I'd have B equals 180 over 20.
I thought we were doing 15 girls.
So the number of boys becomes 9.
Oh.
change, so you can change it.
Yes. The first time through, you use the original comparison to find the K, and then after that, you use the K and the new number given to you to find what you're looking for. Now that's not so bad either, is it?